Hi, this is Tejashu, and I'm back with my lessons on MSP 430X to XX family. It's been a long time that I've been giving the basic introduction to the X to XX family, and now I would like to discuss the registers that are required to be configured for the basic clock module plus. As I had told in my last session that you need to configure the registers and the bits in the registers in order to get the clocking done. And we must remember one more thing, that TI gives a ROM space where all the critical values and some specific values are loaded, like for example in case if you want the DCO to function at 1 megahertz, then the corresponding values are already stored in the ROM space, so you just call bcstl for underscore 1 megahertz and it will be done. So we'll see that in the CCS part of the training session. So let's start from here. I guess we left off over here. So what I should do is I will be basically describing in a very short way how to configure these registers. This is one register, DCO CTL. This is another register, that is basic clock system control 123, which basically will control the clocking system. And this is the interrupt register. I told you this IE1. This IE1 has several bits. Each and every bit is responsible for each and every action from various parts of the chip. So don't bother about the spaces which you don't see. Just concentrate on the interrupt that I am going to discuss about. As I told you in my last class that there is one interrupt that comes from the clock failure, and that is OFIFG flag, and that is associated with it, so which generates or takes the chip to the NMI, that is non-maskable interrupt. So that interrupt, if it is enabled, and if your when the chip powers up, when the MSP powers up, it automatically goes to the DCO, and then you have to write a part of the code that I will discuss today to bring it back to your crystal oscillator, that is either LFXT1 or XT2, whichever is there in your particular chip. And last but not the least is that I am going to discuss with respect to MSP430 G2553, which does not have an XT2. But for you guys out there who have a chip containing XT2, you can have a look at the XT2 library and the XT2 register functions. That will be great for you. So first we go to DCL. Now one thing you must see, that all of these are read-write libraries, right? Which means that you can read from them as well as write onto them. The address space is 056057853, because if you remember the memory space, there's a part of the RAM which is mapped to the 8-bit peripherals, and there is another part of the map which is another part of the RAM which is mapped to the 16-bit peripherals. So these are the 8-bit peripherals, so there's going to be only 8 bits that you need to configure, not 16 bits. And the initial state, as you can see, is basically the state which, or the value which in hex you're going to get back if you read this register. Suppose if you read DCO CTL in the initial state, right, then you are supposed to get back 060. Okay, so that we will see next. So first, coming to DCO CTL register. Now here you see there are only 8 bits. I told you it's an 8-bit register. The first 5 bits, that is 0, 1, 2, 3 and 4, they are read-write registers, and the initial values are 0. As you can see over here, RW0 means the read-write value initially is 0. So the MODX, or the modulation selection, is by default taken as 0, right? And the DCO, it is, you can see it is 1 and 1, that is 3. So the DCO value by default is selected as 3. This was discussed in the last class. You could refer to my previous video. So DCO value is taken as 3, that is 0 1 1, which means that DCO is taken as 3 and the mod is taken as 0. So modulation 0 and DCO is equal to 3 is the default function. You can write any value over here, right? I will show you. There's one thing you need to know, that is, if in case so the DCOX value will be 0 1 1, that is 3, and you can get that over here. That is for the hex value 0x011, not 0x011, sorry, 0b011. That comes to 0x3, and the default value for mod will be 0. So that is the standard value after power up condition, that is 0 1 1, and all the rest will be 0 for the modulation values. So that is how you configure the DCO-CTL register. Then comes the BCS-CTL1 register, that is the basic clock system control register 1. Here, before, in my previous session, it was told that XT2 off is required when we want to turn the XT2 off, that is when we don't need the XT2. Some devices like the G2553 doesn't have the XT2, so this particular bit has no importance. XTS 0 means low frequency mode, 1 means high frequency mode, that is the LFXT1 controller or the oscillator can be connected to a 32.768 kilohertz oscillator, that is a clock, the one that is connected to our wall clock, or the standard crystal of 16 megahertz or 25 megahertz. So if you want to run in low frequency mode, we have to put this 0. If you want to run in the high frequency mode, we have to put this bit as 1. The DVX is the auxiliary clock prescaler. Usually the auxiliary clock supplies clocking to several other peripherals, so we would like to operate it as a slower peripheral as compared to the main clock or the central clock system. So we would prefer as 0 1, that is divided by 2, that is this one, and R cell X. Now the R cell X is the register select. It is the range select for the particular DCO. As we have seen in the graph that R cell X selects the range and DCOX selects the part of the range. So DCOX is default value is 3, and the R cell X, as you can see, that it is 0 1 1 1, that is 0 1 1, which defaults to 7, as you can see over here. So 7 means the middle of the part of the graph. You can refer to my previous session video. So that is 7. So 7 in the RCLX and 3 in the DCOX means that your oscillator will be running, that is the DCO will be running, or the core of the microcontroller will be running at 1 megahertz speed. So this can always be changed according to your requirement. You can always change this, but the changing has to be done in a particular sequence that I will show you. Then it is BCS CTL2, that is basic clock system register 2. Here basically what we are doing is that we are selecting the clock system for the SLM. SLM means the clock system for the submain clock, that is SMCLK. So the SMCLK can be clocked from DCO-CLK if we put this as 00 or 01, that is we put this value as 0 or 1, and for if it is 10, that is 2, the SMCLK will be clocked by xt2, and one that is 3, then SMCLK will be clocked by LFXT1 CLK or VLO CLK, that is very low clock, as I told you in my last video, that is RC control register, RC controlled oscillator, sorry. And then div mx, that is the divider for the main clock. So main clock usually we do not divide, in very rare occasions you would like to divide the main clock. It's a prescaler for the main clock, so usually we go for 0 0. That is why you can see the default values are 0 0. And cls is nothing but select SMCLK. So you can select the source of the SMCLK, like the point remains that why should we do a double selection for SMCLK? You had SLMX before in the bit 7 and 6 and SLS in bit 3. Now whether you want to select the source from the DCO or from the XT2 or LFXT1 or VLOCLK, the first selection has to be done from the SLS, and then whether you want to select it from LFXT1, VLOCLK or XT2 has to be done from bit 7 and 6. And divsx is nothing but a prescaler for your SMCLK. Usually in all our projects we will be running the SMCLK, the SCLK as half, and MCLK in the normal clock. The decode is an important thing, that is DCO register select. This is not available in all devices, that is whether you're using an internal register or an external register for the DCO, that is DC controlled oscillator. Usually we always go for external register, so internal register, so you will see that always the value is defaulted as 0. Nobody wants to select it as an external register, right? Then is your BCS CTL3, that is a basic clock system control register 3. Now XT2SX, this is the XT2 range select. Now if your device has an XT2, which is not in the case of 2perfect3, but definitely in the case of MSP 430 other devices which have XT2 present in it, then if you're connecting a particular crystal, whether it is 0.4 megahertz to 1 megahertz, then you have to put 00 over here. If you're selecting a register of 16 megahertz, sorry, a crystal of 16 megahertz, then you have to put a value of 10. So this particular value you have to select according to the crystal you're connecting to the microcontroller. Now, LFXT1SX, this is nothing but it's a low frequency clock select, and it also selects the range. So I'm sure you can understand that if XTS, which you have selected before, is equal to 0, then your crystal is at low speed mode, or LFXT1 will be operating at low speed mode, and you can select the particular selections, that is 00 is the 32.768 crystal, or 10 is the VLOCLK, or if you are clocking from an external source, then you need to put 11. And if you are using the LFXT1 as the high speed mode, then you just put XTS equals to 1 and equals to 1, and then you can put the particular value according to your crystal. Suppose we will be using a 16 megahertz crystal, so for 16 megahertz crystal we must put 10 over here, right? So by default it will be from 0 to 1 megahertz crystal. As you can see, after the power up condition it will be 0 0, so we have to modify this, right? And finally XCAPEX. It will only be required if you're using the internal capacitors, but I don't prefer using internal capacitors, so it doesn't matter whether you're using an internal capacitor or an external capacitor. I always go for an external capacitor. So uh, preferring the value of 00 is most preferable. xt2 off. If your device has an xt2, then you can put it off in case you are not using xt2. If you're using xt2, then xt2 has to be made present in the fall condition present, that is this one. I'm sorry, this one. Okay, so and LFXT1 off, this is the condition where you put the LFXT1 clock to off condition, that is LFXT1 is not operating. This is the condition when you put the LFXT1 clocking to totally hibernation mode, and your clocking system goes to off. Only the interrupts will be active, and only when an interrupt comes to the system, your system goes into the active state, and your particular interrupt subroutine is executed. Now here comes the most important topic, that is OFIE. OFIE, I think I discussed in my last video. That is, OFIE is basically an interrupt that is required to be enabled when you need to enter into a subroutine where you want to check if there is any kind of oscillator fault. So if there is any kind of oscillator fault, then OFIFG, that is this one, will become high. By default, OFIFG will become high, and once OFIFG becomes high, OFIE becomes high. And if you have enabled OFIE become equals to 1, or if you have enabled the interrupt, then the processor goes for a non-maskable interrupt in NMIE, where you can write some kind of information that there is an oscillator fault. And in case if like OFIFG will always be 1 when you switch on the microcontroller. So OFIFG equals to 1 is the default condition. You don't have to bother about it. So you just need to clear the flag if you're not bothered. If you're bothered, then you need to enable the interrupt, go to the NMI, log, or do whatever you want to do in the interrupt subroutine ISR, and then again come back, before coming back, clear the subroutine of OFIF, clear the flag of OFIFG, and go back to your main routine. So this is nothing but the details of the registers that you would be dealing with. I'm sure that you can just go through the registers and read the descriptions. If you have any kind of questions, it's always welcome to put the questions in the comments below, or the particular area for the comments. You can also mail me at joshua@joshusworld.in, or you can also write me in the YouTube channel. But the main thing that is very important is that your clocking system has to be perfect. That's the reason why I am discussing the BCM as the first important topic, because your clocking module has to be perfectly configured before you can proceed to any other portion of the microcontroller. So I hope that this video clears your idea about BCM, but make sure that you read the previous video, because just reading the registers won't help you out, because you must know the clocking module in details that was discussed in the previous video. So once you are clear with the previous video, then please proceed into this video. And if you have any kind of questions, please don't hesitate to mail me or write in the comments below in the website. So guys, that's all that I want to do in this session. Next session I will configure several frequencies using DCO and BCSCL CTL 1, 2 and 3, and also I'll show you how NMI or how OFIF G flag can make the processor go to a non-maskable interrupt, and that requires Launchpad. So I guess you have a Launchpad. So if you don't have a Launchpad, please buy a Launchpad. The link is given in my website, and follow it. I'm sure you'll be able to gain knowledge from it, because unless and until you do it yourself, you won't be able to gain confidence in it and proceed further. And for the guys who are interested about the next session, well, I'll open the index for you. The next session will be on system resets, interrupts, and operating modes. This is the most important, most vital, and most exciting part of the MSP 430. That's a wonderful processor from Texas Instruments, and it's a low power mode. The most important part is the low power mode, and how you can bring the processor to the low power mode for battery applications. And if your application is very much power consuming, how to decrease the power consumption. All these things will be discovered and discussed in the next session, right? So the next session will be on system resets, interrupts, and operating modes. So once you're done with this, if you have any queries, put it in the question session. I'll answer to it and we can move further, right? So bye bye, have a nice time. Please try it out yourself. Thank you.